Basic data bundle. Is it? Yeah.
Okay, this is the last section, 9.09 and 9.10. So we may have to just go a little bit longer each of these days because I want to make sure we can feel really comfortable with these two today and tomorrow. And then because Monday and Tuesday we'll do a review, but our classes will be cut short. This will be 30-minute class Monday, and it'll be like a 20-minute class on Tuesday. Okay, your test will be it's just a period length test. It's just 2 pages, but give you the first page on Wednesday and then the second page on Thursday. Okay, each day you'll get 30 minutes, so it's really plenty of time. Okay, all right, so have you guys copy down some notes first? So page 25. Okay, so confidence intervals. So here's something that we can make it so that I think it makes sense to us. So let's say you and a friend plan to meet at Six Flags one day, and then you tell them that you'll be there at 10:30, and you do end up there at 10:30. So what time would you expect your friend to arrive? 10:30, right? Because that is your agreed upon time. But would any other time also be reasonable? Maybe your friend shows up at 10:25 or 10:35. At what point would it be, would you expect this friend to be too late? Right, so it can range, right? For some people, it could be 10 minutes, it could be 20 minutes, but 30 minutes is really pushing it, right? If you're waiting for someone for 30 minutes, that it feels like it's a really long time. So now, how confident would you be of your friend to arrive, quote unquote, on time if you make your window really narrow? Like, if you only consider on time to be 1 minute after or 1 minute late, or 1 minute after 10:30 or 1 minute before 10:30, how confident would you be of that person making it on time? Not very, right? But if you have a really wide interval, let's say you think of on time that's 15 minutes after or 15 minutes before, then you're a lot more confident that they're going to be quote unquote on time because you've widened your interval. So the idea is that you're going to be more confident the wider your interval, but you're less confident if your interval is really, really narrow because the chances of them missing that window is greater. Okay. Okay, we've talked a little bit about population versus sample, but we'll talk about a lot more detail here. Thank you. Okay, so population includes all elements of a set of data. And then we'll really come back to this. I just want to kind of introduce that confidence interval. We'll talk a little bit more how it relates to everything here. So all adults in the US, that would be an example of a population. A sample is only a portion of a set of data. So let's say you're only able to survey 3,500 adults, then that's only a sample, right? You're not able to get, now that sample may represent some details about the entire US population, but ultimately it's still a sample. Okay. Now parameter is a number that relates to the population. So uppercase N, that's a parameter. For instance, N is equal to 252 million US adults. Okay? And the percentage of US adults having a college degree, we will use lowercase p, 30.1%. Okay, so that's data. Okay, so that's data for the entire population. But let's say you're only doing a survey out of a sample of the population, then lowercase n will represent that sample. Okay. And then your sample percentage is p with a little p hat, so a little notation above that, like a chevron notation there. That indicates that it's not a population percentage, it's a sample percentage. So of that sample, 28% of adults have a college degree. You're not gathering information about all the adults, it's just the sample percentage. Okay, so let's look at some of these examples here. Identify the population, sample, and statistic for each of the following scenarios. A survey of 1,300 American households found that 32% of those households have basements. So population would be all American households. Sample would be like what the survey indicates, only 1,300 people surveyed. And then because that 32% is coming from the sample, it's going to be that p hats, that lowercase, or that p with a notation to indicate that it's just the sample percentage and not the population percentage. The average bill from every sixth person getting food at Chipotle in a 3-hour period was $19.61. So population would be all customers. Sorry, misspelled. Sample will be every sixth customer in that 3-hour period. And then your statistic is your average, right? So your X bar, your average is $19.61, your average meal cost. So back to confidence intervals. Confidence intervals are intervals of plausible values for estimating a parameter with a given percent confidence. We use sample mean to estimate population mean. We use a sample proportion to estimate the population proportion. Okay, so consider this. Milton Parks and Recreation Department wants to build a new park in Crabapple. To allocate funds to build the park, they need to determine if residents in the area want one. They mail a survey to residents within 1 mile of the proposed location and find that 78% of residents who responded are in favor of building the new park. They'll find the confidence intervals to projects what all resident in the area may think of the new park. Okay, so right now I'm just going to have you guys copy down these notes here, but we'll go over this in detail. And really, we're just focusing on these two formulas over the course of today and tomorrow. Okay. So within each problem, you can we'll be able to know which formula to use based off of what they give us. Either they give us proportion or they give us the mean. So proportion is going to be your sample proportion in decimal. So you're looking for some sample proportion. So it could be 0.50 for, that represent 50%, or 0.49 or 0.86. It's some, we're going to be able to find some probability. Okay, so whatever the probability is in the problem, that's going to be your sample proportion. Now, from your sample proportion, you can also find your z-score for probability. Right, and it's going to be 1 minus c% divided by 2. Okay, we'll talk a bit about that. Okay, n is your sample size. And then your margin of error is this value right here. That's your margin of error. Plus or minus, or whatever comes out of that plus or minus, that's your that's your margin of error. So we'll do z times the square root of p hat minus multiplied by 1 minus p hat over n, all the square root of that. Okay, doubling makes the interval width. Okay, and right now we're just writing down these definitions, but we'll see it on the next page. Okay. And then if we see P, then that's the true population proportion without that notation above. That transforms it from sample to the true population proportion. Okay, so if we're given sample proportion, we'll use this formula. If we're given sample mean, then we'll use this formula. Okay. So X bar is the mean of the sample. Sigma is the population in standard deviation. Z score for probability, 1 minus the C percent divided by 2. N is your sample size. Margin of error is whatever comes after that plus or minus. So it's that Z sigma divided by square root of N. And then mu is the true population mean. We're not probably going to use this too much. We're going to stick with the sample mean. Okay, so let's go to page 26. Okay, so go ahead and put this formula at the top. We're going to start with this one here. And these formulas will be given to you. There's no, you're not memorizing these here. So this is my confidence interval here. Okay, a survey of 50 people found that 84.6% of respondents believed a toilet paper roll should roll over and not under. Construct a following confidence interval for the proportion of people whose toilet rolls over and state the margin of error for each. Okay, so our N is 1150. And our p-value, our percentage, is 0.846. Yeah.
What's the difference between P and then the P with the little?
Oh, I'm sorry. Yeah. So sorry. This is the p hat. This is sample. So it should be this. Thanks. Construct the following confidence intervals for the proportion of people whose toilet paper roll over and state the margin of error for each. So we're going to start with 90%. So that's your confidence percentage. So we are going to start off by finding the Z value here. So 1 minus C percent divided by 2. And we have to use this as a probability here. So Z is equal to 1 minus 0.9 divided by 2. So that's how we find our, get to our z-value. Sorry, this is actually, we have to get to the z-value from here. So 1 minus 0.9 divided by 2 will give us the confidence probability here. So if I do 1 minus 0.9 divided by 2, that gives me 0.05. And we look at our table here. .05. Hold on, wait a second. 0.05. Six. I'm missing something here. Sorry, 1 second. Six.
Thank you.
Okay, sorry, we're looking on page 2 here. We're starting from yeah, so 0.05 is meant to be on page 2. So if I'm looking for 0.05 here, it's closest to negative 1.64 or negative 1.65. So either one is fine. So I'm going to choose a z-score value of negative 1.65. I'm sorry.
Why is it?
Well, these are all the values that are 50% and higher. Anything from 0 to 50% needs to be on page 2. So we're looking for 0.05. So that's going to be, yeah, it's going to be lined up right here, which is negative 1.65. Okay. So we have our everything that we need to build our confidence interval, because our confidence interval is given by this formula. So now we just start putting our information into our formula. So our confidence interval is equal to percentage, so 0.846 plus or minus the z-score. Now the plus or minus is already kind of allowing for a positive and negative value, so we can just ignore that negative here because we're going to do plus and minus. So we can just do 1.65 square root of 0.846, 1 minus 0.846 all over 1150. Now this whole mess here, this is called the margin of error. Okay. That's the margin of error. Okay, so I'm just going to little by little try to get this decimal value, all that cleaned up. So I'm going to multiply this through, divide by 1150, take the square root, and then multiply by 1.65. I want to get this piece here down to a decimal value, so I can just have an easier time kind of working with it. So my margin of error, I'm working on trying to clean up my margin of error into an easier value. Okay, next. One 8. I'm going to just round it to 0.018. So my confidence interval is going to be 0.846 minus 0.018 or 0.846 plus. So that's my margin of error. Okay. So then my confidence interval is going to be between two values. It's going to be whatever's on the lower end versus whatever's on the higher end. So if I do 0.846 minus 0.018, that's my lower bound. And my upper bound is going to be 0.846 plus 0.018. So 0.828. And then I'll do a plus in between. So this is only a 90% confidence interval. So this is going to be a little bit more narrow. But if I have a 95% confidence interval, I'm going to be even wider because you know, the wider I make my margin of error, the more confident that I'm going to be for me to land within my target. Okay. So part B here, 95%, everything pretty much will stay the same. The N will stay the same. The P will stay the same. The only thing that we really have to adjust is that C%. So we have to convert that C% to a decimal. So let's first get to our Z-score value. So it's 1 minus 0.95 divided by 2. That's 0.025. Look on page 2 to get that Z-score that matches with 0.025. So that's negative 1.96. So my Z-score is so we repeat the process. The only thing that we're changing is this negative 1.96, but everything else stays the same. And so really between A and B, everything else stays the same. It's just that we're changing that Z-score from 1.65 to 1.96. And we should be getting a larger margin of error because we want to have a higher confidence. So with a larger margin of error, we're going to have a wider margin than before.
that like the 95 and 90%, or is it like the answers in advance?
If I want a 95% confidence, I'm gonna have 95% confidence if I set my interval to be these two. Okay, any questions with one? Again, I'm going to go a little longer with today and tomorrow's class, just because this is going to take a while for us to get enough practice in. Okay, so let's look at number two. Number two says, in a sample of 2,500 people, 770 people separate their Skittles by color before eating them. Construct an 85% confidence interval for the proportion of people who taste rainbow with colors separated. So here, they don't give us that percentage. So we have to build that percentage ourselves. 770 divided by 2,500 is going to be our percentage. Now, n is still 2,500, but here we just have to do that additional step of getting that percentage for our p-value. So we know n is 2,500. But then our p-value is going to be 770 divided by 2,500. We make our calculator do the work there. We'll get 0.308. One minus 0.85 divided by 2. From there, we'll get our z-score. So look on page 2, 0.075. That's really close there. So negative 1.44. Okay, so that's a hard part. Everything else, you're just using the formula because you have everything in front of you now. So p plus or minus the z square root of p, 1 minus p all over n, square root of that. Again, the number that follows the plus or minus is your margin of error. Because the number of people that we are surveying is 2,500 people. Yeah, the total number that we're surveying is your n value. So again, p plus or minus z square root of p times 1 minus p all over n. And then everything that follows after the plus or minus is your margin of error. And you'll do 0.308 minus the margin of error. That'll get you your lower interval, your lower bound. And then 0.308 plus your margin of error will give you your upper bound. Okay, let's do number 3. Number 3 says a recent survey of 133 million students found that their average daily screen time is 5.402 hours. If the population standard deviation is 1.565 hours, construct the following confidence interval for the average daily screen time for all students and state the margin of error for each. So here, we're given a different set of information. We're given confidence interval for the mean, and they give us standard deviation. So we're going to transition over to this formula here. So I'm going to copy that down. Again, these formulas will be provided for you on the test. And this is going to show up on next Thursday's, the second page of your test. So the first page of your test won't have confidence interval. This will show up on the Thursday portion of the test, right? Your test is next Wednesday and Thursday, so.
So the first part will just be what we had on the quiz.
Exactly, yeah. And then part two is this.
So still no math.
Yes, but you can use your calculator to get that
Oh,
information.
okay.
Yeah.
So
Okay, number three. So let's gather our information. We know our X bar is the average daily screen time, so that's 5.402. Standard deviation is sigma. It's a little bit cleaner. It's not do as much work here. Our N value is what? Yeah, N is 133. To get to the Z, we still have to go through that process of 1 minus 0.8 divided by 2. That will get us to our probability. From our probability, we gotta get that to the Z score. Okay, so again, look on page 2. So we're looking for 0.1 on page 2. It's the closest one there. Negative 1.28. Okay, so now we can build our confidence interval. We'll start with X bar, 5.402 plus or minus 1.28 times 1.65 over square root of 133. Again, the value that follows after your plus or minus is your margin of error. So if the problem ever asks you for just the margin of error, you're just going to provide this 0.174. But if you don't want to do the confidence interval, then you have to involve the plus or minus with the mean. Okay, I want our goal just to be able to finish this page here. So let's try part B with 99%. With 99%, the only thing we have to really adjust for is the Z score, right? Once you get to the Z scores, then everything else is the same. So try part B, and then we'll try to do number 4, and then that'll be it for today. Again, the only thing that's changing between A and B is that percentage that's causing the Z score to be adjusted to a different value. But other than that, everything else stays the same.
Like 2.57, 2.5, because they're both 2 off.
Yeah, if they're both too off, I'm gonna give that flexibility and pick one, yeah, so.
So anytime they give you any sort of an average, then you know you're gonna use that that easier formula with the X bar. And also, the giveaway is standard deviation, right? If they mention standard deviation, you know you're gonna be using that formula. And then, the probability formula, is that first one. Okay, try number 4 as well. And you use the same formula as number 3. Okay, number 4, average, that's your X bar, 6.303. Sample size, 540, sample size, that's N. Standard deviation, that's sigma. 88% confidence interval. Go through that formula, 1 minus 0.88 divided by 2 to get your probability, convert that probability to a z-score. And once you get your z-score, then you have everything you need to build your confidence interval. Okay, so we're just going to be continuing working with these types of with this topic tomorrow as well. Okay, all right, come and get your phones.